Hello and welcome to all students in this our YouTube channel. Students, we are in the topic of structure of atom, and this is very important chapter according to your theory as well as competitive examinations. Students, in our previous lecture we have seen the introductory part of this chapter, and in that part we have covered the discovery of protons, neutrons and electrons. Students, along with that knowledge, we will go to the next part of this chapter, that is composition of the atoms of the first 18 elements. Students, you already know about the 18 elements which are present in the periodic table, that are I have mentioned in this chart: name of the element, their symbol, atomic number, number of protons present in that corresponding atoms, and neutrons, as well as number of electrons. And students, in our previous lecture we have also completed how the shells are present in the atoms which are we have taken here. For example, that is in its the distribution of electrons also, how it is present we have shown in this table along with its corresponding valency. Now students, let us observe this chapter. Then you will notice that atomic number as well as how many number of protons are present in it, and electrons, neutrons, etc, etc, all this knowledge you will get here. Suppose students, we will going to take an example of carbon here. Carbon has atomic number 6, and all of you already known that the atomic number is nothing but its number of protons, so number of protons are also same. And if you come to the point number of neutrons, this may be different for some elements, but here for carbon it will be 6. And if you look at the number of electrons, they are nothing but the equal to the number of protons, that is 6, because a whole atom is a neutral. So the protons as well as the number of electrons are same. As well as if you look at its distribution, if you look at its distribution in first shell, that is K, and in second shell, you will notice that in carbon first shell the number of electrons are 2, and in second shell number of electrons are 4. And if you look at its valency, it will be 4, because to complete its octet it requires 4 electrons. So this is all about what we can say the carbon. Students, we will take the another example which is something different than that of this carbon, and it will be sodium. Students, sodium has symbol Na, and this Na comes from Latin word, that is natrium. And if it look at its atomic number, it will be 11, and number of protons are 11. If you look at its number of neutrons, it will be different, that is 12, because if you look at its atomic mass, it will be 22.98 in the periodic table. So we have considered it as a whole number, that is 23. And if we come to the point to calculate the number of neutrons, it will become 12, and the number of electrons are 11 here in the sodium. And if you look at its distribution in the different shells, then in K shell the number of electrons are 2, and in L shell 8, and in M shell 1. So student, this is the distribution of electrons. And if you look at the valency, the sodium element has valency 1, because in its outermost shell it has 1 electron, and it becomes stable by losing 1 electron. So this is the about what you can say the valency. Students, like that similar examples you can take for your practice. So this is about what we can say the composition of atoms of the first 18 elements. Let us move to the next part of this chapter, that is atomic structure of the first 18 elements. Students, these are the different shells which are we have taken in our previous table, means how the electrons are present in the different shell, as well as if you look at its uh, valency, you will notice that K, L, M, these shells we have shown in this our presentation. And after that we will come to the important point, that is valency. Valency is the combining capacity of an element. The electrons present in the outermost shell of an atom are called valence electrons. If an atom's outermost shell is completely filled, they are inert or least reactive, means less reactive, and their combining capacity or valency is 0. Students, if you look at its means valence electrons in sodium, now just previous example I have explained it. Sodium has 1 electron in its outermost shell, means the valence electrons are nothing but 1. And after that, if you look at the elements which are inert or least reactive, and their combining capacity or valency will be 0. Of the inert elements, helium atom has 2 electrons in the outermost shell, and the atoms of other elements have 8 electrons in their outermost shell. Means the elements which are already satisfied by electron, means those atoms which do not require the electron, we are calling it as a least or inert elements. Atoms having 8 electrons in their outermost shell is having octet configuration and are stable. We are calling it as a inert elements. Now students, if an atom outermost shell is not completely filled, it is not stable. It will try to attain the stability by losing, gaining or sharing electrons with other atoms to attain the octet configuration. So students, this is the very important point that you have to take into account. The number of electrons lost, gained or shared by an atom to attain octet configuration is the combining capacity or valency of the element. This is the definition of what we are calling it as a valency. Students, for example, we are going to take here the hydrogen, lithium, sodium atoms can easily lose 1 electron to become stable. So their valency is nothing but 1. And in our previous explanation, we have seen the sodium atom. You can also take that example. Magnesium can easily lose 2 electrons, so its valency is 2. Aluminum can easily lose 3 electrons. If you look at its electronic configuration in its outermost shell, there are 3 electrons are present, so it becomes stable by losing 3 electrons, so its valency is 3. Carbon shares 4 electrons, so its valency is 4. Now students, one element, that is carbon, it becomes stable either by losing 4 electrons or by gaining 4 electrons. So this is nothing but what we can say, the intermediate element. Now students, like that of if we consider the fluorine can easily gain 1 electron and become stable, so its valency is 1. So overall we can say that valency is nothing but the combining capacity of an element. Now according to that, if you look at oxygen can easily gain 2 electrons, so its valency is 2. Nitrogen can easily gain 3 electrons, so its valency is 3. So if you look at the valency, you have got what is meant by valency and for which element how much is the valency. So students, this is a very basic information that you should know about before going to start the electronic configuration, as well as to go in detail of these elements. Now students, atomic number and atomic mass, this concept we have already seen in our previous chapter, that is some basic concepts of chemistry. Again here we are going to repeat this point because this point is the part of this chapter. Atomic number, students, we are going to denote it with the capital letter Z, and atomic mass number, which we are going to denote with the letter capital A. Now students, the atomic number of element is the number of protons present in the nucleus of the atom of the element. All the atoms of an element have the same atomic number. This sentence you should be remarked. Students, we will learn some examples which are related to it. Hydrogen, which is having the atomic number 1, that is it contains 1 proton. Helium has atomic number 2, number of protons are 2. Lithium has atomic number 3, number of protons are 3. Students, one point you should also point out here, that is number of electrons, because we have already stated that number of electrons as well as number of protons are always same. So you can also count, instead of protons, electrons also here. Friends, we will move to the next point, that is mass number A. The mass number of an element is the sum of the number of protons and neutrons present in the nucleus of an element, or you can say atom. The mass of an atom is mainly the mass of protons and neutrons in the nucleus of the atom. That is, with some examples you will get the details of their corresponding example. If we take an example of carbon, which has the mass number 12, means it contains 6 protons and 6 neutrons, its mass is nothing but 12 unit. Students, if you look at the aluminium, mass number is 27, 13 protons and 14 neutrons, and it has mass of 27 unit. If you look at the example sulfur, mass number is 32 and it has 16 protons and 16 neutrons. Mass is 32 unit. Means in the notation of an atom, the atomic number and mass number, we can show it with this symbol, that is for nitrogen I have mentioned here 7 is at the base and 14 is at the upper side of the nitrogen, means at the superscript. The number which is present at the subscript is nothing but its atomic number, and the number which is present at the superscript in the periodic table, which is called as the atomic mass number, that is capital A. So students, this is all about in our today's lecture, and in our next lecture we will learn what is meant by isotopes and isobars. So this is all about in our today's lecture. Thank you very much.